Right, morning IGs. This is going to be a teaching video on chapter 14, which is called linear programming. So this is a new section for us now. Okay, so what we've got on the screen, you can see I've just got my X and Y axis. We can label them quickly if you'd like. There's X and there's Y. And you are already familiar with drawing graphs. So you've done some straight line graphs. So let's do a little bit just here to have a look and see what we've got. I'm going to look at exercise 14.1, which is just some revision. And I'm going to look at number A, which says the following. Now, 15, it says, plus 3x is this time less than 21. So this is not an equal sign now. It is a less than sign. Okay. All right. So let's rearrange this. So we're going to keep the 3x on this side, but we want to take the 15 over. So just like we do with the equals, we just go all the way over, and that becomes minus 15 on that side. So 21 minus 15. Now, what is 21 minus 15? Well, 21 minus 15 is just 6, okay? And now we want to say, well, that's 3x must be less than 6, so what is x? Well, that simply means we can divide both sides by 3, and so 6 divided by 3 happens to be 2. So x is less than 2. Now the question is, how do we illustrate this on the Cartesian plane that we've got? So where is x equal to 2? Well, if I did some divisions here and I made a 1 and a 2 and a 3, so this would be the point of 2 over there, okay? So that's where x equals 2, that's the x point. And x is actually equal to 2 all along this line, okay? If I draw a nice straight line, I didn't use the ruler now, maybe I should. Let's just actually take that line away, and let's just put the ruler here. So everywhere along this value of x equals 2. X is 2 everywhere along that straight line. Does that make sense? So let's draw that straight line in. So there x is less than 2. Or sorry, x is equal to 2. Now, if we want to illustrate x is less than 2, it means that we can shade everywhere on the left-hand side of that number 2. Everywhere, okay? Because everywhere on the left-hand side of 2, the x values will be less than 2. So that would illustrate what we've got as an inequality there, x is less than 2. Now, strictly speaking, I'm not 100% yet, for the simple reason, okay, that this line x equals 2 is a solid line, and that means it includes 2, but my inequality is not x is less than or equal to 2, it's strictly x is less than 2. So the way we illustrate this mathematically is to make the line not a solid line, but a dotted line. So what I'm going to do is just make some holes in our line. Okay, so now when I shade everything to the left and I make a dotted line, I have illustrated this inequality over here. Okay, that's this inequality over there. So we've illustrated that now on the graph. Okay, and this is something we're going to be doing. We're going to illustrate on graph paper some of these inequalities. Okay, so that's actually what the first little section has done, even though they've just done one or two examples in the beginning to solve. Okay, they've now used that on the next page, page 149 and page 150. Okay, so let's have a look quickly. I think the best is just to do some examples. So I'm going to start with exercise 14.2 now, and then take you through some drawings. Okay, so let's just erase everything here. We'll just delete everything. That's going to be better because I want to keep the axes there. Right. So exercise 14.2, the first question, number A, says, by drawing appropriate axes, shade the regions which satisfy each of the following inequalities. All right, so what have we got here? We've got y is greater than 2. Now, where is y equal to 2, first of all? Let's just put my y back over there. Well, if I'm marking here, and I draw a 2 over there, remember the next one will be 3, this is a 1, okay, there we know that y is equal to 2 everywhere along the straight line that runs parallel to the x-axis. This is the line y equals 2. Let's make it 0 degrees. Oh, it just wants to go back. Okay, there we go. Right, so let's run a straight line through there. That line that I've just drawn is the line y equals 2. Okay, now if that's y is equal to 2 and I want everywhere that's greater than 2, okay, then I'll have to shade everything above the line. Yes, so everything above this line is y is equal to greater than 2. And remember, because I also don't want to include the line y equals 2, I'm going to have to make this a dotted line. Okay, so now we've illustrated y is greater than 2. Okay, I'm going to leave number B because we had a look at something similar to that already, but I do want to now do, let's do number C, which is y is less than or equal to 4. Okay, so again, I'm just going to erase everything here, and less than or equal to 4. So we'll have to make a value for, there it is. So y is less than or equal to 4. Okay, so first of all, we'll need a straight line again. That is y is equal to 4. That's one of the things we need anyway. So let's draw it. There it is. And to illustrate where y is less than or equal to 4, we will have to shade everything below that line. This time the line is solid because we want to include the equal to. Okay, so this time the line is solid, it's not a dotted line. Okay, so let's get a little bit more fancy now with number E. Okay, number E says y must be greater than 2x plus 1. Okay, so this time let's go and see what our inequality looks like. Alright, so I'm just going to erase these. Right, y must be greater than 2x plus 1. So the first thing is, let's see what y equals 2x plus 1 looks like. Alright, now remember this is the format for a straight line, and you should be familiar with straight lines. Okay, this value is the gradient, this value is the y-intercept, or the c value. Okay, now since it says y equals, that means we can go and plot it straight away. So first thing we want to do is we want to go and plot that value of the 1, because we know that the line will cross the y-axis at 1 because of the c value over here. Are you happy with that? We also know that it's got a gradient of 2, which if I write as a gradient a change in y over a change in x, the value is 2 over 1. Okay, that means that the change in y is 2. Now I always suggest to everybody when they're drawing gradients of lines, okay, we always choose up for the y. So what we want to do is from that 1 we want to go up 2 units. Okay, that gets us to the 3. But then the 1 suggests we have to move either to the left or the right. Now since it's a positive 1, okay, and you might say, well, how do you know it's positive? Well, there's no negative signs here. We're going to move to the right just 1 unit. So this is where x is equal to 1. Okay, that means it gets to this point over here. And then I can do the same thing. I can move another 2 up. That would get me to 5. And then I'd move 1 across to the 2. Okay, so 5, 2 would be a point on the graph. There's the 2 on the x-axis. This is 5 on the y-axis. You can see those dots are in a straight line, okay, and they would form a straight line, and that would be the graph 2x plus 1. That would be where y is equal to 2x plus 1, but they wanted greater than 2x plus 1. So that means that everything must be above that line. So again, we're going to shade everything above that line to illustrate the following: greater than. There we go, it's greater than 2x plus 1. And of course, because it's strictly greater than and not equal to, again, this dotted line, or this 2x plus 1 line, has to be a dotted line. Does that make sense to you? Okay, so it's very important that you illustrate these things accurately as you go. I'm going to do the last one there, which is the y is less than or equal to x minus 3. Y is less than or equal to x minus 3. And again, we'll undo everything and just get back to our Cartesian plane of the x and y axis. Right. So here we go. X and y again. Let's just put in y and x over here. And we want to illustrate y is less than or equal to x minus 3. Well, again, if we had y is equal to x minus 3, we'd know that the graph would cut at minus 3 on the y-axis, because that's the c value. The gradient for in front of x, or the value in front of x, is a 1, which means it's just 1 and 1. So that means going up 1 and to the right 1. So there is a point on my graph. Okay, then we go up 1 again and across 1. And so we could plot a straight line that looks like that. Now if y has to be less than x minus 3, it's got to be everything on the bottom end of the line, because it's a less than, it's below that line. And of course, if it's there and it's got to be equal to as well, we can leave the line solid. And so we don't need to make a dotted line for this one. Okay. All right, that gives you exercise 14.2. I'm going to ask you to do the following ones. So listen carefully as the homework. You can do 2b, 2c, and 2e, and 2f on that lot. So that's just 4 examples there to keep you busy on this section. I'm going to move on to the next section, but I'll do another video for that. Okay, so enjoy the rest of this one, and I'll see you soon.